All right. So we're looking at how you solve logarithm equations, and there's really two ways you're going to do this. First one is similar to the solving exponentials with common base. Okay. One of the rules is you want to make sure you condense logarithms using log properties. So if you don't know those, or if you don't, or at least if you know where they are, just get them from. Use them or have them in front of you to do this. Okay. Second thing is that when we have log with common bases, all we have to do is set the argument equal to each other and solve it. So it's very similar to that, okay? And then make sure we check for extraneous solutions. This is where you probably will need a calculator. And what extraneous solutions mean is that if you get an answer, you're going to plug it back in and see if does it actually work. Okay, and the other thing also is that we'll probably be using some factoring methods. So I will tell you where those will pop in here in a little bit. Okay. So the first thing is solving a basic logarithm. So when you have a logarithm with a common base like this, you just essentially can cancel the logarithm out and set your argument equal to each other and solve. Okay, it is that straightforward. Do a little bit of algebra. So you get 2x is equal to 18. So you factor x is equal to 9. And then when you check for extraneous, all you do is you take, does it work? So if I do, hold on. Nope, I don't want absolute value. Sorry, log base. So log base of 3 of 7 times 9 minus 1. I get that answer. And then if I do the second one on this side, log base 3 of 5 times 9 plus 17, I get that answer. Since they match up, this is the good answer. It's not considered extraneous. So if I had done this and the answers I got here were not the same, or it gave you an error, like you can't do it, then that answer is considered extraneous automatically. Okay. Same here. Natural log and natural log are the same base. So we set the argument equal to each other. Now, this is a quadratic, so it means the only way to solve this is to set it equal to 0, which is what I'm going to do. Minus 5k minus 14 is equal to 0. And then you have your options of using quadratic formula or factoring. I'm going to factor because this one works nicely with factoring. So two numbers that will multiply to 14, but add to negative 5. I think that would be x minus, this is a k, not a x. 7 and k plus 2. So therefore my two values would be negative 2 and a positive 7. So basically, because this is a k minus 7, this has to be positive. This is the k plus 2, this has to be negative. Okay. So what happens when you have to condense? Well, condensing basically says this. Since I have an addition problem, I'm going to make sure and multiply. So if I put these together, it'll become the log of 4 times c plus 3 is equal to the log of 8. Then you can eliminate your logarithm, and you get 4c plus 12 is equal to 8. So 4c is equal to negative 4, so c is equal to negative 1. And again, you can check to make sure that this side works here. So log of 4, and I'll show you. So log of 4 plus the log of negative 1 plus 3, is that the same as log of 8? They match up, so we're good with that answer. Okay. Again, coefficient rule becomes an exponent here. So I'm going to eliminate the logarithm. So 4p plus 3 is equal to 16p to the 4th to the 1/2 power. And I'm going to do some simplifying here. So 16 to the 1/2 power is 4. And then 4 times 1/2 is 2, so 4p squared. It's another factoring problem, quadratic. So I'm going to do some work here real fast. Minus 4p minus 3 is equal to 0. And then I'm going to do some factoring again. So in order to get 4p squared, I'm going to do 2p and 2p. And then in order to get, let me see. This minus 3 and this right here, I'm going to use minus 3. And if that's minus 3, this has to be a plus 1. Now, I know this doesn't give you a negative 4 in the middle, but 2 times 2 is 4. So this is 4. That's 6, which is where the minus 4p comes from. And then my two answers, since this is 2p plus 1, my answer for this one is going to be a negative 1/2. And the reason why is because I just basically move my number back underneath. Okay. This one right here is going to be equal to positive 3/2 for the same reason. And that's how that works. Okay. Now, the other way you're going to see this is using exponents to solve logarithms. So here's what I mean by that. So the rule basically says, again, condense and isolate, rewrite in exponential form. So that's that rule 7 or rule or circle rule, whatever you want to call it. And again, I check for extraneous solutions the same way. So here's what happens. So instead of setting this equal to a logarithm, I take my base and rewrite it as an exponential instead. And then I solve it. 2 to the 7th power is 128. And again, use your calculator, folks. Do a little bit of algebra. Again, and then plug it back in, see, does this give you 7? If it does, it does. Oh, this is not 144. Sorry. 132 divided by 3 is 44, not 144. I don't know where I wrote 44. Okay, just like that. So again, you can check it. So log base 2 of, what is that? 3 times 44 minus 4. And it gives me 7. It works out. Good answer. Okay. Natural log. Natural log is automatic base e. So e to the 9th is equal to 2a. So divide by 2. So whatever this is, so e to the 9th, divide that by 2. It's 4051. So a is equal to 4051.54. Okay. Let's see. Condense it down. So it means I want to make sure and get logarithm by itself. So add 5 to both sides. Convert. Solve it. Done. Okay. Let's see. Isolate first. And this 2 you can do one of 2 ways. I'm going to be honest with you. Just divide it out. It'll make life simpler if you do it that way. Okay. Convert. So 9 to the 1/2 power is equal to k squared plus 2k. This is another quadratic right here. 9 to the 1/2 power is 3. I'm going to actually end up having to use a little bit more space on here. So this becomes 0, which is what I want. And then to factor this out, two numbers that multiply to -3, but add to 2 in the middle. So that would be k plus 3 and k minus 1. So my two answers would be k is equal to a -3 and k is equal to a +1. Okay. A lot of this is a lot of Algebra 2, Algebra 1 stuff. So we're just kind of rehashing that at this point. Ugh. Okay. I'm going to skip a step here. I know I'm going to have to multiply this times this. I also know this is going to be 4 squared. So I'm going to rewrite that exact way to save some space. Kind of like that. Okay. I'm going to go ahead and multiply this together. It's called FOIL method. So 16 is equal to 2v squared, 6v minus 6v minus 9. It's not too bad. I'm going to add 9 to both sides. Equals to oh, hold on. This is not a 2. This is a 4. I'm trying to figure something out. Why 2v times v is 4v squared, not 2v squared. So 4v squared divided by 4 to both sides. Okay. So v squared is equal to 25 over 4. If I square root both, I get v is equal to plus or minus 5 over 2. Now, if I check both my answers, what's going to end up happening is this -1 is going to be extraneous. So let me write these out separately so you can kind of see them. So v is equal to positive 5/2. V is equal to a -5/2. We're going to reject this guy because he's not going to work. Again, you can always plug it back in and check it. So the only answer we have is this positive v over 2, 5 over 2 answer. Okay. Then let's see what we got here. Again, multiplied it, adds to multiply. 1/3, so 27 to the 1/3 times x minus 5 is equal to 4. No, I don't know why I did that. This is natural log. Okay. So this will become 3. Distribute. 3x minus 15 is equal to 4. Base e, so e to the 4th is equal to 3x minus 15. I'm going to add 15. Now, I'm going to do all this at one time. So it'll be e to the 4 plus 15 is equal to 3x, divided by 3 to both sides. So that's what I'm going to plug in the calculator. It is actually more accurate to do it this way. Okay. So here's what I'm going to do. So e to the 4th plus 15 divided by 3 is 23.199. Okay. And that's solving the logarithm. I know they get a little bit more complex as you get further on. I get that. So, but there you have it, folks.